Hello students, so today we will studying one more application of dimensional analysis. This is quite important application, means how we can make a relation in case we know what are the physical quantities on which it depends. It will be clear from this example. Like suppose you know that the period of oscillation of a pendulum may depend on the mass, on the length of the pendulum and acceleration due to gravity at that place. I only by judgment I know this thing. Now how to make an equation? So the procedure is, we will write that time period t is proportional to m raised to a, l raised to b, g raised to c. So we write in this manner because I know it depends upon these three parameters. Where k, so now I will remove the sign of proportionality and put the sign of equal to. So my k will come where k is dimensionless constant. Where k is dimensionless constant. I explained you last time what is dimensionless constant. So now I want to find the value of a, b and c. So the procedure is, we have learned principle of homogeneity of dimensions. So dimensions of left side and right side should be same. Dimension of m on left side is 0, l is 0, dimension of t is 1. So now I will equate it to the dimensions on the right hand side. Right hand side, m is equal to capital M, l is equal to capital L, g is equal to l into t raised to minus 2. But now all are having index. So my equation would be this. Left side is only t, k, m raised to a, l raised to b and acceleration raised to c. Now by principle of homogeneity of dimensions, here m is 0, here m is a. So my a is equal to 0. Here L is 0, here L is B and also here C. So B plus C. So B plus C is 0. And in this case, this is minus 2C, this is 1. So minus 2C is 1. So this is by using principle of homogeneity of dimensions. Now this is an algebra. A is 0. I got. So from here C is minus half. So if you substitute c is minus half, you will get b as half. So you will get this answer, b as half, c as minus 1. Now to substitute in this value, you will get t is equal to k root l upon g. So this is the equation of the pendulum. Now by experiments, they have found the value of k is 2 pi. So I will say k t is equal to 2 pi root l upon g. So in this manner, we can make an equation or find the relation between various physical quantities. Okay, so now we'll go to next. Now next sum says, planet is moving around the sun in circular orbits. Now we know that period of revolution t is depending upon radius of orbit r, mass of the sun and gravitational constant g. So we have to say so dimensionally that t square is equal to r cube. Now you see, so what we will write, t is proportional to r. He says depends upon also r raised to a, m raised to b, g raised to c. So this, then we will remove this proportionality sign, put an equal to sign, so I will get this equation where k is dimensionless constant. Now we will equate the indices or dimensions on both the sides. So first, here there is a capital T. So this, it is capital T is T. R is measured in terms of L. So R is L. Mass is M. G has got this as dimensions because G is equal to this. We had calculated in some example. So when we substitute these values in this equation, I will get this as the answer. Now I will simplify this, and so I am getting this equation. Here I had only t, so it will become m0 L0 t raised to minus 1. Here L raised to a, L raised to 3c. So I have simplified, so I am getting m raised to b minus c, L raised to a plus 3c, t raised to minus 2c. Now by principle of homogeneity of dimensions, both dimensions of both the sides should be same. So 0 is equal to b minus c, b minus c is 0, a plus 3c is equal to 0, and minus 2c is equal to 1. Okay, so when I solve this equation, I will get the answers, and I can substitute here. So I will get this answer: t square is equal to k square r cube upon mg. So I can see that t square is proportional to r cube, because k is constant, mass of sun is constant, g is constant, all these three are constant. So t square is proportional to r cube. So I have proved. Is it all right? This is quite simple to do. Now we'll go to next sum. This is also similar. Here we are given a large fluid star, means it is having some liquid and gas. It is oscillating in shape. It is changing its shape, oscillating its shape because of its own gravitational field. So using dimensional analysis, he says find the expression for period of oscillation t. So t is proportional to, in terms of radius of star r, so t is equal to r raised to a, mean density of fluid rho, rho raised to b, and universal constant g, g raised to c. I have written k, so I made equal to. Is it all right? Now to put the dimensions of all the terms, r is in L, densities you know, it is m raised to 1 L raised to minus 3, g you know, we have used many times, it is m raised to minus 1 L cube t raised to minus 2, the whole raised to c. Now left hand side can be written as m raised to 0, L raised to 0, t raised to 1. Those who equate, and you will get the answer as b is equal to minus half, c is equal to minus half. So t is equal to k into 1 upon root L. So you see, now you are able to derive the formulae, a relation between physical quantities. But this method has got certain limitations. So try to understand these limitations, so that you cannot do find any equation in physics by using dimensional analysis. First is that by you have seen that we cannot get the value of constant k. For this we have to do the experiment, like I have got k here. Second limitation is, in case if a physical quantity depending upon the sum or differences, like we know v is equal to u plus at. So such solutions where there is a plus or minus, we can't use. Here only multiplication allows, directly proportional, indirectly proportional. Then you cannot have a relation in case there is a trigonometric, logarithmic or exponential function. In case it depends upon trigonometric, sine of something, cos of something, log, exponent, this method will fail. And in case the physical quantities on which it depends are more than 3, then you can't use, because left hand side we have got 3, m, l and t, we are using it. And sometimes you may not be able to judge properly the physical quantities on which it depends. So these are the limitations of this method. Otherwise, but definitely this method is quite helpful, or in verification after they found out the equation, to confirm that it is right. It will only tell that dimensionally it is right. Is it all right? So this completes this topic of dimensional analysis. Now from next session we will do error analysis. Thank you. I hope you have enjoyed this sessions on dimension analysis. So please subscribe to the channel and like it and press the bell icon so that you will get notification when I post the next video. Thank you.